Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is the third video in our Python adventure. So what I'm going to do is I'm going to make this a little bit bigger. Okay, and I'm going to head over to the Python console, because what we're going to do now is, let me see if actually if I type in clear, does that clear this? Nah. Okay, I wonder if I do this. Let's give this a shot. If I do that. Run. Okay. Let's see what this does. Aha, there we go. So what we're going to do is just show you some operators. I'm going to use the Python console, the REPL, to do this because it'll just be faster. You can do pretty much anything you want. First, just mathematical operators. So there's the addition sign, where we can add numbers together, or concatenate strings, as we saw in the previous video. But you can also minus 5 minus 5. You can do 4 times, which is the asterisk. So 5 times 5, or 4 times 4 equals 16. And then there's the division symbol, which is 5 divided by 9, or 7 divided by 9. And we get a float in that case, a decimal number. Cool. Now, the one mathematical operator that people oftentimes aren't aware of is modulus. So if I were to do this, for percentage sign, which is modulus, 2. Okay, I get 0. Now, how does that equal 0? The way you want to think about modulus is, the way I think about it is pizza. I have 4 slices of pizza and 2 friends. If I were to evenly divide my pizza among my 2 friends, how many would I have left over? What's my remainder? So let's see here. I have enough to give each of them 2. And if I gave each of them 2, there would be none left over. Now, if I did 5 modulus 2, so I have 5 slices of pizza and 2 friends, I can still give each friend 2 slices of pizza. But I don't have enough to give them a 3rd slice of pizza. So in that case, I have a remainder of 1. Okay? And usually how this is used is to determine whether a number is divisible by another number. So if I would say the number 15, is it divisible by 3? Yes. Because technically, if a number is evenly divisible, you should have no pizza left after distributing. So I can test whether a number is divisible by testing whether modulus results in 0. So I can be like, if this equals 0, whatnot. Cool. I don't think, in other languages usually have like increment and decrement, which I don't think exists in Python if I remember correctly. So let's try that out. So increment would just mean add 1. So I would just do like 5 plus plus. And yeah, it doesn't look like 5. Yeah, so see, it doesn't have that. Okay. So let's talk about Boolean expressions. Boolean expressions are ones that evaluate as true or false. And let me just make this a little bit bigger. True or false. So for example, if I were to do 5 is greater than 6, 5 is not greater than 6, so that's going to be false. But if I do 5 is less than 6, that'll evaluate as true. Now, how about equality? Does 5 equal 5? So it's 2 equal signs. Because remember, 1 equal sign was assignment, so 2 equal signs is equality, meaning are they the same thing? So is 5 the same thing as 5? Yes, it is. But is 5 the same thing as 6? No. Is 5 not equal to 6? So are they not the same thing? Yes, that is true. Okay, is 5 less than or equal to 6? True. Okay, is 5 greater than or equal to 6? No. Okay, so you have Boolean expressions, and you can do compound Boolean expressions. So does 5 equal 5? And does 6 equal 6? So both have to be true. So first we'd say 5 equals 5. Yes, that's true. 6 equals 6. That's true. Are both true? Yes, so this should evaluate as true. I think it was just one. Okay, let's try that again. Oh, okay, so let's try that again. 5 equals 5. Is it just 1 ampersand, or maybe it's just 1 amp? Or I think actually in Python I have to write it out. You know, so many different programming languages in my head. And 6 equals 6. There we go, yeah, so it's 5 and 6 equals 6. And let's see if I did this. 5 equals 5 and 6 equals 7, which is false. So while this is true, but this is false, they're not both true because it's an and. So I get false. But if I made this an or, so is this either one true? Well, then 5 equals 5 is true, so that's true enough. Okay, so those are the different operators you have to work with when it comes to doing operations in Python. Okay, the Boolean operators are particularly important because you need them to do what's called control flow, meaning controlling how the program kind of moves in different directions. Okay, so let's see here. Let's create a variable called num, and we'll say num equals 5. And what I want to do is create different possibilities of what the program can do. So I'll say if, so if's our first control flow statement, meaning if whatever is inside the parentheses is true, so if num is greater than 4, so 5 is greater than 4, so that's true. And then what you do is you're going to put a colon, and that tells Python that we're going to bundle some stuff, some code within this if. So in the next line, you have to do a tab. So this is what makes Python sort of unique. Usually other languages, you have to wrap everything up in curly brackets, which gets a little tough to manage sometimes. Python, to make it much more readable, they got rid of the curly brackets, but there had to be a way to know which code belongs to the if statement and which code doesn't. So it does this through tabs. So you have to be very, very careful with the way you line up your code. So if num is greater than 4, which it is, then we will print num. Okay? But that's all I want to happen there, so I go back, and I'll go back to line up with the if, because now I'm outside of the if. And what I can do is I can use what's called an else statement, which means if it's false, do this instead. So I would put a colon again, and then a tab for the code that belongs to the else, which will be print not greater than 4. Okay, and then when I'm done with what's the else, I can go back to the main to the main alignment, and then I'll print this happens either way. Okay, so now if we go back to our terminal and type in python 3 testing.py, okay, right now 5 is greater than 4, so we should get the true version, which would just say print 4 or print 5. So prints 5 and says this, and then this happens either way, because this line of code is not part of the else or the if. So it happens when this whole block is done, whether it's true or false. Well, if I change this to 3, 3 is not greater than 4, so this should get the opposite scenario. So see, not greater than 4, this happens either way. So that's an if statement. Here's where we can start having our code sort of branching in different directions. And again, here's where we start seeing that we need to print tabs as our code branches off. And you can have branches and branches. So I could say in here, if num equals 5, so specifically if it's 5, then it will do this. Print it's 5. It is 5. Else print num. Okay, so you can have, and you see it's another tab, so it just keeps tabbing in there as you have these branches. Okay, and basically everything's got to line up right. And this is where having an IDE really helps, a good editor that kind of helps you manage all that tabbing. Cool. So now if I run this code now, and let's change this back to 5. See, it is 5. Okay, because it basically said yes, it's greater than 4. Yes, it's equal to 5. Well, let's say I do 6. See, it says yes, it's greater than 4, but it's not equal to 5, so it's just going to print the number. So you can start creating all sorts of really sort of fun branches with that. Okay. So now we know how to put information to the screen. We know how to do some branches. Now, what would be another fun command in Python is input. So what happens is that you can ask for information from sort of the user, but we need to store that in a variable. So we'll create a variable. So we'll say, hey, data1, and that's going to equal input. So the input function means, hey, ask the user for something. And then in there you can put the statement that it says when it asks the user for stuff. So give me a number. Okay. Then we'll ask for another piece of data. Data1 equals input. Give me another number. Okay, we're going to call that data2. So let's change that to data2. And then we can use that piece of data. So we can do print and say, you, let's do that with interpolation. If we add these numbers, we get data1 plus data2. Okay, and it'll just do that operation and then interpolate whatever we return into the string. So let's run that. And see, it says give me a number, so I'll give it the number 6. And then I'll give it the number 6, so let's say it should give me 12. And it says if we add these numbers, we get 66. Ah, now why did it do that? The reason is that input, even though I gave it the number 6, it returns it as a string. So it thinks data1 is the string of 6, not the number 6. So basically what happened is that this ended up giving me back 6, not 6. So how do I fix that? What I could do is change it into an integer. So I go int, that's the function to change it into an integer, and wrap this in parentheses and do the same thing here. So that way it takes the result. And the way you want to think about how functions run is that it always starts from the inside first. So first thing that happens is this. So this gets the string, it'll get the 6. And then this function happens that takes that 6 and turns it into a number. Okay? And now this should work. So let's see here. 6, 6, and now we get 12. Because instead of adding 2 strings and concatenating them, it is taking 2 numbers and adding them. Okay? So again, just another illustration of why typecasting is important, and kind of understanding what type of data you get back from a function is important. So I'll see you guys in the next video, and we'll start playing with loops. Ciao.